Let's talk about graphing quadratics in standard form. I'm going to take us through graphing just one equation, and that's this one. Now, there's a few different methods you can take, as with pretty much everything in math. There's more than one way to do most things, but especially when it comes to graphing quadratics, there's two major paths that people like to take. Either they will take this equation here, they'll find the vertex, create a table, and plot some points, or you could rewrite it by completing the square and transform it into vertex form. In today's video, I'm going to do the first of the two methods. I'm going to go ahead and find the vertex, and then I'm going to plot some points on either side of the vertex and then sketch the graph from there. So when you're in standard form, you've got your coefficient on x squared we usually refer to as a, and then your x has a coefficient we call b, and then your constant we call c. And then using these values of a, b, and c, we can find your vertex. All we need to do to find the x value of your vertex is take the opposite of your b and divide it by 2 times a. And this will be the x coordinate of your vertex. But of course, an ordered pair is an x and a y, so you've only got half of it right now. So what we need to do once you get that is take this x value and then plug it back into your equation to figure out what y value goes with that x value. So this is the method I'm going to use here. My a, b, and c value from my equation are -2 for a, my b is -12, and then my c is -15. And then I plug them into my formula for x, -b, my b is a -12. Notice I have those double parentheses to make sure that I'm not dropping either negative, and I've got all of my pieces over 2 times, and then again, I'll put parentheses. Whenever I'm substituting in, I always like to put parentheses just to make sure I don't miss anything. And then from here, those two negatives give me +12, and then 2 times -2 is a -4, which means that my x value is a -3. But again, I've only got half of it. I need the whole vertex. So I know what x value we're at for the vertex, but I need the y. So I'm going to take that x value and go back to my original equation up here and plug in that x value. So my original equation, y equals -2 times x squared. I'm going to leave it blank because I'm going to go back and plug in the x in a second. And the same thing with the -12x, I left it blank so that I can easily throw in that -3 now. And then I follow my order of operations, exponents first. I'll go ahead and multiply these two as well because they're not attached to anything else. Multiply, and then I will go through and add everything. So my vertex then has a y value of 3 and an x value back up here of -3. So my vertex is at the point -3, 3. Now that I know where my graph is, I'm going to go back and create a table and plug in some points on either side of that vertex. So let me go ahead and clear what I've got here. We'll make the table and then we'll sketch our graph. Okay, so I have my coordinate plane ready to go and my table. Since I know that my vertex is in the middle of my graph, I'm going to put it in the middle of my table, and then I'll pick 2 numbers higher and 2 numbers lower. So I will go to the right and do -2 and -1, and then to the left, I'll do -4 and -5. I'll start by plugging in a -1. Now, something I know about parabolas is that they're symmetric. So since I have my vertex in the middle of my table, I know that everything on either side of that is going to map to the other side. So the -1 that I have here is going to map down to -5. So that will have the same y value as my -1. So both of those y values are -5. And again, this is only because my vertex is in the middle the way that I formed my table. So everything in equal increments around that vertex is going to have the same y value. So then for the same reason, when I go plug in this -2, whatever y value I get is also going to be the same y value as my -4. So let me go ahead and do that now. So I get a y value of 1, which again will map down to the other side of my vertex because of the way I've constructed my table. So now I've got everything I need. Let me go over to my coordinate plane and sketch my graph. And there is the graph of our parabola. Something to point out, this point right here is my vertex. And that point has the coordinates -3, 3. Something else that we found without actually saying that we found it was our axis of symmetry. And that's the line that goes right down through the middle of your graph through that vertex. And it has the equation x equals whatever that x value of your vertex is, so -3. So really, when I started this whole thing, I found my x value by using this formula. Well, that's the formula for your axis of symmetry. You know your vertex is on that line, so we use that formula, and then we plug it in to get the y value. So this formula really gives us the axis of symmetry, but it's also the x value of your vertex. And that is one of a couple options of graphing a quadratic in standard form. Hope that helped. Thanks for watching, and I will see you next time. Bye.